Hello students, welcome back, and today we are going to continue our series on SPM revision, and previously we did until question number 3, and today we are going to do question number 4. A student conducted an experiment to study the relationship, and let me highlight the word relationship, between mass and inertia. So which one is the manipulated variable, which one is the responding variable?
Manipulated is mass and responding is inertia.
Yeah, so it's the mass, responding is the inner responding variable will be the usually the first
No, oscillation time.
mass or oscillation will be the responding
The
variable.
responding, yeah.
Oh no. Inertia is represented by the oscillation time. The result experiment, so again I think it's near to it is inertia is still the responding variable, because the bigger the mass, what they want to show is the bigger the mass,
The bigger the inertia.
the bigger the inertia. What is inertia?
How to say? Property of matter by which it continues in its existing state of rest or uniform motion in a straight line.
Yeah, okay, it's a tendency of what tendency of an can you say again?
A property of matter by which it continues in its existing state of rest or uniform motion in a straight line.
Okay, so they are talking about a matter. Okay, a matter will continue at the state of rest or at the state of a certain motion that probably will resist the thing, even though when you stop it is still moving. That's called inertia. Of course, if you have a lorry with a sand, then there is a very high huge inertia, because if we go up in 80 kilometer per hour, and a car that is crashing on a brick wall of 80 kilometer per hour, so which one got more damage, the lorry or the car?
The lorry.
The lorry. Why?
Because the mass is bigger.
The mass is bigger, it has a bigger inertia, so it continues to have its motion, which is 80 kilometer, or it's continues to have its rest. So yeah, so it shows this. Okay, but for this experiment we are not using lorry to do the experiment. We are going to use the mass of a pendulum. So we just take a pendulum and we just maybe we put 100 gram, 200 gram, 5 kg. Of course, the heavier something, the thing will move longer. If it's lighter, it will very fast finish. So this is how we want to test it. We are not using a lorry, we are not using a car. Use the diagram table to draw a graph of the oscillation. So okay, they asked me to draw. Okay, so what is the first thing to do? First thing is just to draw the straight line. So I just draw the straight line. I draw this one, a straight line. And here again, oops. Here also I draw a straight line. Okay, maybe I like to put an arrow up here. Then what's the next step I should do? Label. So here is 100. So you count 100, 200, 300, 400, 500. So manual variable is at x or y? This is x. This
Y.
is y.
Y.
Manipulated variable.
No.
Manual variable will be always at the x-axis. You don't do this one wrong means you totally wrong everything. Manual variable will be always the x-axis. So 100, 200, 300, so it's 1, 2, 3, 4, 5. And we look at this, we can count 1, 2, 3, 4, 5. Okay, so I just put here 100, 200, 300, 400, 500, 600, 700, 800. I should just now I should draw the line here, but never mind, I already draw. your graph must be always how many percent bigger? Only your graph must be big. It must be at least 75% or 70% of your graph paper. You don't draw small, at least half lah. At least it must be half of the paper size, not small, then you get wrong. Okay, so I already draw the unit, and this one is 5, 10, 15, 25. So maybe I put here 5, 10, 15. I cannot. So I just put here 5 lah, what to do. 5, 10, 15, 20, 25, 30. What should I do now?
Mark.
Yeah, mark. But I think I should put the title
unit
for X and Y. Yeah. So what's the?
Yeah.
So this one I put what?
Mass.
Mass, and the unit will be gram.
Gram.
Okay.
Yeah.
Just put gram, a bracket, so that no is a unit. And this one on Y axis.
Oscillation time.
Oscillation time. Okay. Oscillation time. And the unit minute.
Minute, yes.
Yeah, okay, because here it's minute. So don't forget lah. If you forget this one also, you minus one mark. Not minus one mark. They will say mark not given. So mark not given means no mark lah. So mark will not be given if you lack of details information. So after you draw this, label it, make sure this one student always forgot one, the unit. This one is because if you don't write the unit, it could be mean kg, it can be ton, it can mean a lot of things. Okay, let's make this quick. 105, 210, 315. So 105, 210, 315, 400 I don't know, 525. So from here, you need to what? You need to draw a line. So from here, I can conclude that this is a linear line. Like mathematics lah, we have linear, we have graph, we have the curve one, curve up, curve down, or maybe it's sometimes it curve up, then it go up. So how you know? You know by seeing the dot, by seeing the X, and then you need to make judgment on what you want to do and what does it show. Because sometimes the X it will be like, sometimes it will be like this one, and then student will confuse. Oh my goodness, what is this? What should I do? Then they might draw like arrow up down, which you eventually will get it wrong. Because even though it is up down, I might want to draw a straight line, because this is the best fit line. We call it the best fit line. And why you want to draw a best fit line? It depends on the title of the research, what you want to do. Because let's say you are wanting a relationship of mass and inertia, a straight line shows that the higher the blah blah blah, the higher than blah blah. So it brings meaning to the hypothesis of the research. So you no need to draw zigzag. It's confusing to the reader. Just draw a straight line, and it shows if this increase, this increase. That's the main objective of a research paper that you want to do. Okay, anyway, so we got a straight line, and then you got all the unit properly, you will get 2 marks. What is the relationship between mass and oscillation time?
Okay, the bigger the mass, the longer the oscillation time.
The bigger the mass, the longer the oscillation time. Okay, so I just put the greater lah. Greater the mass, and then what? The
longer.
The greater oscillation time. Okay, very good. 1 mark. Based on the diagram 4a, state the oscillation time when a mass of 400 grams used. Write down your answer. So if you use 400, then what is the answer? We use 400.
400.
400.
20.
So it will go to here. Up to you lah if you want to draw arrow here. So it will be 400, go up, go left. You will get 20 what? Minute or second?
Minute.
20 second.
Oh, second.
Why second? Why second?
Eh?
Why 20 minute lah?
20 minute ah, not bad.
So the answer will be second. Why? Because I think the question write wrongly. I think this one will be second. Because it doesn't make sense.
Yeah, that
You want the pendulum to swing for 10 minutes. What? I think he want to, the question or sometimes they ask is number of swing per minute. So if you want to write per minute, it makes sense. Or the time is second, but it doesn't make sense when you say it's minute. So can the pendulum swing for 25 minutes? So no, right? So I think this is a error in the question. Previous 2 years ago, there's a mistake in SPM paper, and I don't know how they mark. And hopefully this year is not, because it's a maths paper and it come out in the news. Eventually, I asked my maths friend, they also cannot do, and it waste. I don't know lah. I hope it don't waste lah. I mean, like for you student, if you don't know, especially for maths lah, if you don't know, just skip the question. You spend like 1 hour to do the question. Eventually, that is the question that got the problem. So you might want to skip it first. To those students that didn't skip and try their best and waste a lot of time in the question, then pity them lah, pity them. Predict the oscillation time if a 600 gram mass is used. So if you use 600, what is the time if 600 gram?
600.
Yeah.
25 oh?
So 600 is here. You go up, it will be going to here. Oops.
25.
So it will go to here. It will go to 25. What's the unit?
Second.
25 second. Hey, 25 second. Did I do wrong? Why the answer is 31? Wait, let me see again. If 600 gram of mass is used, 600. 5, 10, 15, 20, 25. Oh, here is 30. No wonder. Okay, here is 30. Okay, so the answer is correct. Okay, so it will be 30 second. Okay, of course the answer is 30 second. Plus minus 2 or 1. Plus minus 2. Okay, means you can write either 30, 31, 32 or 29, 28. Okay, plus minus because it's a graph paper. Okay, any question?
No.
No question. Let's proceed with section B. Answer all the questions in this section. Diagram 4.1 show the structure of atom. What is X? What is Y?
This is a electron.
X is the electron, okay? Why?
Because it's outside.
No, I mean why? This Y.
Oh, why? Y is oh, sorry. Y is a neutron.
Neutron, yes. Oi, don't get this wrong, bro. So it's very easy. Neutron. Okay, so in every atom that we see, the element that we see, if I want to cut it to be very, very, very small, I cut until something very small, we call it an atom. Eventually, the last time definition throughout the history, they say atom is something that is, one of the definition, atom is something that is so small that you no longer can able to cut it. But after a few more years, they prove this wrong because eventually they can split the nucleus. And what is the reaction called when you split the nucleus? You split the
nuclear fission.
Nuclear fission. Fusion is a combination.
Fusion is a combination.
Fission is the splitting. So eventually, the recent years, for the World War II, they managed to figure out how the atom split that produce a lot of energy and use it to bombard Hiroshima and Nagasaki. Yep, very nice. And now we can even split it, and we even notice inside that is called quartz. That you haven't studied lah, quartz. I can draw lah, 2 up quartz or 1 down quartz. And what is even smaller than the quartz, I still don't know. And one day we are going to find it out, and it's a whole new world, like what the Ant-Man always see, that you how big you want to see something,
Yeah.
and how small, and you can continue to study even the quartz. Now I think we look at quartz lah. One day I hope we can even see what is inside the quartz. What is the charge of X?
Charge of X.
Can? Okay, and obviously the charge is negative.
Oh, negative.
Negative, of course, the charge they say. Many
okay.
definition, the number of charge, the percentage charge, and just now we Google, we see the column, which is they're talking about the electrical charge. Yeah, it's negative, and we can see proton, pro, also positive, start from P, and Y is the neutron, which is neutral, which there is no charge. So the charge of X is negative. What is the nuclear number in this atom? Nuclear number. So this whole thing will be this whole thing is nuclear number. Nuclear number equals to what? Nuclear number equals to proton plus what?
Neutron.
Neutron. So proton plus neutron, 6 plus 7, how many you will get?
13.
13. So the number of nuclear number in this atom is 13. Diagram 4.2 show the structure of 3 atoms. 1, 2, 3. What's the question? Which atom are isotope? Tick correct for your answer. Which one is isotope?
Isotope is same number of proton and same of proton, right? So it's first and second, no?
First and second, very good. Okay, we know that the proton number cannot change. Isotope is the element that has the same number of proton but different number of neutron, or you can say same number of proton but different number of nucleon. I mean, it's the same thing anyway. Nucleon, neutron, it's just the same, huh? Okay, which atom are isotope? Or this one? Based on diagram 4.2, what is an isotope? So what is an isotope?
Atoms with same number of protons.
What?
Same number of protons.
Same number of proton?
Yeah.
Like this, does it? So it is an element that has, you correct already, the
Same
same
number of proton.
number of proton. Okay, but what? But what is different?
Different number of neutron.
Different number of neutron. Okay, very good. Okay, so I see you again. Thank you very much. I see you again in the next class. Okay.
Alright. Next year, of course, next week Chinese New Year.
Chinese New Year. So I see you after Chinese New Year.
Yeah. Okay.
Okay. Bye bye.
Bye. Thank you.
Thank you.